All right, so this will be the last lecture before I get back next week. Yay! So, this is the last part of this little ecosystems unit, and we need to talk about measures of habitat health. So, when we're talking about habitats, it's not just how big the habitat is that we're protecting, but it is the individual quality of that habitat. So, for example, if we would have like a giant monocultural field, so mono means one, culturals crops, so a giant field with like one species of plant, it doesn't matter how big that field is, that is a crappy habitat because the quality of that habitat's not great because it's not very biodiverse. So, the example that I have here is in eastern Canada, so like right above us. Moose were pretty much wiped out by clear cutting that forest because they couldn't tolerate a loss of more than half a square mile to their habitat. So, the range that those moose would live in, when just a half a square mile is clear cut out, they can't exist because they don't have enough food to actually eat. And it was also the loss of very specific species that could cause losses in this moose population. So, for example, if we would go in and only remove conifers from their habitat, it would still be really, really detrimental to their population. So, the greater the size of a habitat, typically the greater the biodiversity, the healthier that habitat tends to be. So, with that, we need to keep in mind the maintaining of native species and minimizing invasives, minimizing habitat loss in general. So, with this, we also talk again about ecosystem resilience. So, when we have higher amounts of biodiversity, that ecosystem tends to be more resilient. So, loss of some species really affects this more than others. In regular bio, we talked about this with otters. So, loss of those top keystone species matters way more than losses of non keystone species. So they kind of play a disproportional role in the ecosystem. So in our otter unit in regular bio, we kind of said all species are created equal, but some are more equal than others. That is referring to those keystone species. One example of this that happened in the United States was with bison. So down below is a picture of a bison. A lot of people call them buffalo. They're bison. Their scientific name is actually bison. So that is a bison. And these bison live in grasslands. So the climax community of those ecosystems is, in fact, a grassland. Girl, you fine. So when bison actually graze down that grass, they increase the biodiversity because when grasses grow up, they're not all the same height. Like some species of grasses grow faster than others. So when bison continually mow down that grass, they actually increase the biodiversity because otherwise those grasses that grow faster than the rest of them would just grow taller and then shade out all of the rest of the grasses and take over and make it a monocultural habitat. But when bison and other grazers come in and keep everything grazed down, that increases the biodiversity and allows different species to like flower at different times and produce seed. So when they produce, in the example I have down here, early sprouting grass species, the bison allow those later flowering species to actually become established. And it promotes biodiversity. So if you guys want to pause the video and talk about this for a couple minutes, that'd be great. So, are some species more valuable than others? So, use the term producer and keystone species in your example. So, producer is super important and keystone species super important. All right, so now talking about human managed ecosystems. So these are areas of the United States that are farms, fisheries, parks, residential areas, all of that different stuff. So down below, I actually have a map of the United States, and this is from the late 80s. So this map would be very, very different today because there is less farmland now. But this is percentage of farmland by county. So as we notice, that farmland is primarily in the middle of the United States. So often we call that the grain belt. The reason why there's not a lot of farmland where my cursor is here and right here is because those are mountains and it is very hard to farm mountains. So it's not saying that there's no agricultural impact in those areas, because a lot of those areas are area for grazing and other secondary agricultural things like logging. These are just primarily farms. So when we have a lot of human activity, which is where all of these farms are, it typically is going to reduce the biodiversity, because when humans manage an ecosystem, we have like one purpose, like grow corn rotating with growing soybeans. That is primarily like what fields in Wisconsin are, or growing corn, soybeans, winter wheat, corn, soybeans, winter wheat. Um, so it kind of sucks some of the biodiversity out of that area. When we raise cattle as well, we typically eliminate competing herbivores, carnivores, unproductive plants. So those are plants that the cattle really don't eat, in order to get one ecosystem service. So that is provisioning of food. So making cattle and getting food for people. Um, when we focus on one thing in the ecosystem, it is going to hurt the rest of the ways that the ecosystem helps us. So, nutrient cycling, okay? When we are just having cattle on the land, we're not necessarily focused with nutrient cycling, and the soil becomes really, really poor. When we do high input management, so we are putting in crops that have really, really high yield, it sucks a ton of nutrition out of the soil, and it actually like makes the soil really, really poor. It makes more runoff. So we are now kind of understanding this, and we're focusing on strategies that increase soil health. One of those ways is with something called no-till farming. When we have areas that are no-till farmed, we plant a crop, we harvest the crop, and then we actually leave some of that dead organic plant matter on the field that can rot and add nutrients back into the soil, and it actually reduces runoff as well. So some kind of cool ways that farming technology is actually cycling back. But the take home message from this down below in bold is, when we have one ecosystem service that's maximized, the others are typically reduced, and it reduces biodiversity as a whole. Okay, so how does a function of a human managed ecosystem differ from that of a naturally occurring ecosystem? So when humans manage, it's typically for one purpose. Natural ecosystems can provide food, they can provide shelter, they can provide all of these different things that we typically don't manage for. Okay. And when we are talking about these changes, we also have evolutionary pressures and evolution that come into play. So we used to have mammoths in North America, which I think is pretty cool. They're pretty cool animals. Mammoths, mastodons, different animals like that. At the end of the last ice age, we had a warming climate, and the traits that the mammoths had became less advantageous for them, with their very, very large body size, their thick fur coats. They weren't as competitive in their environment, and they all died off. These beneficial mutations did not occur quickly enough. So there might have been some mammoths that lived a little bit longer because maybe their coats were a little bit thinner. But those evolutionary changes didn't happen fast enough. When we think about elephants, which are their closest living relatives, their gestation period is like 2 years. So So elephants are pregnant for like 2 years. So the changes that can happen in those species aren't very fast at all to adapt to a changing climate. Unfortunately, this is happening again. So our climate, whether it is human caused or natural, we're not going to get into that argument because we really honestly aren't 100% sure. Um, the world is getting warmer. Like if we look at Europe this summer, they had weeks that were above 100 degrees. Like tons of people died of heat stroke. Crops were decimated in Europe because of the heat. And because of this, animals and natural species are also dying. And we are not seeing a lot of evolution happening very, very quickly in a lot of these species. And we are having another mass extinction due to our change in climate. So, with extinction, that means that every single member of that species is eliminated. Current rates of extinction are much, much greater than normal. And we are really estimating right now between 4 and 6 species per hour are becoming extinct throughout the world. And we know this from fossil records. So obviously, everything that dies doesn't make a fossil, but using some mathematical algorithms, we can actually figure out how many species perished in each extinction. And hang on a second. I had to find her plug and put her plug in. So all of these species really affect or are really influenced by high biodiversity. So for humans, we might think like, oh, biodiversity of natural systems, that doesn't matter to me. But it does, because that's where we get our food. We get our medicine from these areas of high biodiversity. And if these areas cannot provide us ecosystem services like clean water, healthy soil to grow crops, different things that we use for shelter, we will also go extinct. And it's not going to happen in your lifetime or Greta's lifetime, but eventually it will happen if we don't take notice and try to maintain what we have. But it's also a really, really weird, careful balance of how much are we impacting keeping things alive that should not be alive. You know what I mean? Like, the environment is changing. Should we be keeping alive species that cannot successfully live in these changing environments? So it's a very, very careful balance of what we actually can change and what we can impact, and should we? Okay. So, why do some species disappear? And how have these rates of extinction changed over recent decades? Okay. And why does it matter? So, if you guys want to pause the video, take a couple seconds, discuss these different things, really, really important stuff to the existence of humans, essentially. So, if you guys want to pause, then come back in a couple seconds. Oh, wow, you're back. All right. So, this slide here in the notes kind of sums up everything in this unit really, really nicely. So if we have warm temperatures, sufficient moisture, adequate levels of sunlight, this increases rates of photosynthesis. When we have more producers because of more photosynthesis, that can then support everything in higher trophic levels via more production of biomass, so living matter. These increased levels of plant biomass allow for more living organisms. More living organisms makes more biodiversity. More biodiversity makes more mutations that can lead to successful natural selection. More biodiversity is greater ecosystem function and ecosystem resilience. So this whole slide kind of like sums up this whole unit in a neat little bow. And I hope that kind of all makes sense to you guys. So this is our last set of notes before I get back, and I will see you guys next week.